Okay, so last thing to add to your card is how to graph. And we have to do one of these. You got to see this happen for it to make sense. You're going to put the center on, and using the slopes you figured out, you're going to count rise over run, and you're going to get the dotted lines on there for the asymptotes. So you're essentially going to have a center, and you're going to have some dotted lines. Third, you're going to plot the vertices. Say ours is horizontal. We're going to go A units over from the center. If those are our vertices, then all I'm going to do, last block they were like, seriously, this is how we draw them? You literally from those vertices just curve out toward the asymptotes. So you're literally just going to curve toward the asymptotes, get as close as you can, but not touching them. It's a little weird at first. So we're ready to start a problem. Woo-hoo, doggies. You'll have to woo louder than I can woo. There you go. This is a very powerful woo. So I figured what to do that. I got one already made. So let us try one of these puppies, and I'm going to put some pizzazz in it. Oh, rats. Thank you. No. And they missed that. So we're going to complete the square identically with ellipses. Now, the one thing don't do, and I intentionally did this problem this way. Which variable is first? It's 16y squared. Why do you suppose they put the y first? Yeah. Okay. And it's positive. It's 16y. The x is negative. So yeah, this is going to end up being vertical. Don't reverse it. I have some people who insist on moving their x's first and their y's second, and then it messes them up through the whole problem. They did it for a reason. Trust them. The y's are first. So what's the first thing you have to do? Yeah. Get the y's together. Leave a gap. X's together. Leave a gap. What do you want to do with 609? It's moving to the other side. All right. Now, can I go divide everything by 16 and get rid of that 16 out front? No, because over here on the x squared, I don't want to divide by 16. That won't work. So yes, we're going to pull it out front just like we did yesterday, which is y squared minus 2y. Here's the one place where we make a teeny tiny itty bitty mistake. What are you pulling out on the x's? A negative 25, since there's a minus on that. So if you're pulling out negative 25, what happens to the 150? That becomes a positive 6x, actually. So make sure you realize that when you pull out that negative, it's going to change your signs. Okay, then complete your square. What completes it if it's a negative 2 here? Half of that's negative 1. Square is 1. Okay, and then the other place where we make a mistake on these is to multiply by that 16 out front, because it's in the parentheses. So 1 times 16 is 16. And I would add 16. And then what's half of 6? 5 and 3 squared will be 9. And then I have to take it times the negative 25, which will be negative 225. So on these kinds, out here, you'll always have a hyperbola. You'll always have one number you added and one number you subtracted every time. Now the good news is when you add those three numbers up out there, it's a nice round 400. So then you have to go back. What quantity squared did you make out of that trinomial? Y minus 1. Bring the minus 1 down. That's why I write it there. And then that'll be x plus 3. Make sure you put your squares on the outside of the parentheses. Last but not least, what do I do? Divide by 400. And magically, 16 cancels into 400 25 times. So 25 goes into 400 16 times. So I'm left then with y minus 1 squared over 25 minus x plus 3 squared over 16 equals 1. And so now I'm in standard form. That minus stays out front. You don't put it down on the bottom. And it's okay that your y's are first. That's perfectly fine. Now, because I did one that y's are first, think before you answer, what's the center? Is it 1, -3, or -3, 1? Yeah, that's x in that parenthesis. So therefore, that's the x coordinate over here. So x is -3, y coordinate is +1. So watch your variables. Okay, will it be horizontal or vertical? This one will be vertical because y is first. Okay, and then how do you know a and b? A is which number? The first number. But that's a squared. So if a squared equals 25, that means a is, and if b squared equals 16, then b is actually 4. That's the major things, but now they're going to ask you the extras. They want to know where the foci are, so what do we have to find? C. Okay, on here, c squared equals what? Yeah, this is normal Pythagorean theorem. It's a squared plus b squared. And so, if a was 5, it's 25 plus 16, 41. You don't get a nice C very often. So, it's an ugly square root of 41. I asked you to actually write me the coordinates of the foci. Okay, so you have to look at your card, and you look at the horizontal part of your card or the vertical part of your card. The vertical, this was a vertical one. Since it's a vertical one, what did it say you do to get the foci? And since it's vertical, you want to go up and down. You have to go up and down to get to each focus. So you're going to add it to the y coordinate of the center. H and K are the center. So all you're doing is you're taking the center, which is at -3, 1, but we're now going to go plus or minus our ugly square root of 41. They'll also ask you for the vertices, which is the exact same thing you just did right there, except you add which letter. So you'll go -3, 1, plus or minus, let's say, 5. Okay, if it's nice numbers, which this is, you need to work it out. So what is 1 minus 5? So that'd be the point, -3, -4. And 1 plus 5 would be 6. So when we get it graphed, our vertices better be sitting in those two coordinates. That's kind of a double check. Oh, the other thing I didn't have to do. Slopes of the asymptotes. A over B or B over A? Since we're on vertical, if you look on the vertical part of your card, slopes would be A over B. So in our case, A is 5 and B is 4. Didn't come through. plus or minus 5/4. That's really important when we go to graphing here in a moment. Okay, graphing time. What did it say you should do first? Center. So center is -3, 1. We have a center. Now this is the part that seems weird. Now the asymptotes, using their slope. You know asymptotes go through the center, so that's your start point. Our slopes were 5/4. So if I do rise over run, I'm going to rise 5 and run 4. But those slopes are positive and negative. So that means I can rise 5 and run 4 in all directions. So I could have done rise 5 and run 4 to the left. I can also do down 5 over 4 in both directions. You should end up with a box. Where should you put your asymptotes then? They go through the corners of the box and the center. So you should be able to just run asymptotes right up through there in both directions. Okay, last but not least, I got to get the curves on there. It said plot the vertex, because the base of the curve, where the curve bends, is the vertex. Which letter gets me to the vertex? A gets me to a vertex. A is 5. So am I going up and down 5, or am I going sideways 5? Which way does this hyperbola go? It's vertical. Since the y's are first, going up and down 5. What do you have, the color? If those are where my vertices are, this is the part they were skeptical about. You literally just curve out and follow your asymptotes. Get close to your asymptotes, but don't touch them. They're not going to be letter perfect curves by any stretch of the imagination. But you got the basic gist of your curves. Yeah. The distance from center to a vertex is A. And so that distance has to be whatever A is. In this case, A was 5. You've already figured A. So I had to go 5 units out. And I went vertical because my y's were first. If it had been x's first, I would have counted 5 sideways. Plus, you have a double check. If you've done the vertices here, maybe 3, -4, check. 3 over, 4 down, do I have a vertex there? Yep. 3 over, 6 up. Bingo, my vertex is there, so I know I didn't screw it up. But the vertices you calculate should be the same as what you actually graph. So, haven't I talked to you about how many points this is worth come test time? If I had to do one where you completed the square, found all the parts and drew the graph, that's probably a 25-point problem. Yeah. I won't have you complete the square on all the different shapes, all the different conics. I'll probably have you complete the square twice total on the whole test. Because it just takes too long.
If you have like a missing number, if you're doing it, you can't figure it out on the test, then you just
Fix it, keep going, come up with an equation. You know, if you get done and you end up with bad numbers on the bottom of the fraction here, change it to something nice and finish graphing it.